Alright, welcome to this page of the notes, and again we're still continuing with this objective, this learning target of solving absolute value equations. So far we've looked at some really simple ones where all we've had to do is split them into the positive and the negative option, solve both options, and then we just check our answers for the exact reason we're about to look at here. We've also looked at now this idea that the absolute value must be by itself on whichever side of the equal sign it's on. It can't have anything else with it before you split it up. So we then got some practice moving stuff around to get that absolute value by itself. And then we also just looked at the idea that an absolute value can never be equal to a negative number. Absolute value represents a distance can never be negative, and so if that happens, absolute value is equal to a negative number, it's just simply no solution. We're actually going to add one more thing here. The reason I asked you to check your answers when it comes to these absolute value problems is because sometimes you will solve the absolute value equation. You will do all of the math correct. Your algebra will be perfect, and yet you'll still get an answer, a solution that does not work. The fancy word for this is an extraneous solution. Oh, I'm not trying to cross it out. Hold up. I want to highlight that. There's my highlighter. This is going to be an extraneous solution, which is an answer that is not an actual solution to the original equation. That's why you got to check your answers. All right? So we're going to go ahead and try this next one here on this page. Let's give it a shot and see what happens. First thing I got to do is check to make sure that my absolute value is all by itself. It is. So we're all set to go ahead and do the positive and the negative version, negative options for this absolute value equation. Now I'm going to do the positive one, so that is going to be x plus 10 is equal to 4x minus 8. Let's go ahead and solve this one since we're here. Then we'll go ahead and do the negative one all at the same time as well. It looks like the easiest way to take care of this, work smarter, not harder. Positive numbers are always better than negative numbers. You could move the 4x to this side, but then you're going to wind up with a negative number, and you could move the 10 to this side, but still negative numbers. If we just go the opposite direction, everything stays positive. So I'm going to do a 4x. I'm going to subtract the x from this side, and that's going to leave me with 10 equals 4x minus x is a positive 3x. I keep my positive numbers. It's good. Positive numbers you're less likely to make mistakes with positive numbers than negative numbers. One of the most common we call them simple mistakes in algebra is forgetting a minus sign. Algebra 2 students forget minus signs. I forget minus signs all the time. So if I can avoid minus signs, I'm going to avoid minus signs. Let's go ahead and add the 8 to the other side. I got my minus 8 here. We'll go ahead and add it to both sides. Once again, that's going to help me keep positive numbers. So now I have 18 is equal to 3x. Symmetric property to flip it. 3x is equal to 18. Divide by 3, I get 6. Check it. Check your answer to make sure it works. Let's do some mental math. I'm going to plug a 6 in for x here, and I'm going to plug in a 6 for x here. So I am going to need to make a little note here because that's a lot of stuff to keep track of. 6 plus 10 is 16, absolute value of 16. I get 16 on this side. All right. Let's do the same thing over here. 4 times 6 is going to be 24. 24 minus 8, positive 16. Hey, 16 does equal 16. This guy checks out. We're all set. Let's go ahead and do the negative version. See what happens. I'm now going to have x plus 10. And a quick note to watch out for. Now I need to make this side of the equation negative to account for the negative option. But in the past, there's only been one thing over here, a number over here, so we just make the number negative. That is no longer the case. I now have two terms over here. This is a binomial over here on this side. So when I add the negative sign, when I make this side negative, I'm gonna have to distribute my minus sign. So make sure you put it in parentheses. That will be your guys' little hint. Hey, I'm gonna have to distribute that minus sign. So let's go ahead and take care of that. Negative 4x plus 8. Once again, I'm going to go ahead and want to try and keep things positive if I can. So the best way to do this would be to add 4x to this side. That's going to give me 5x plus 10 is equal to 8. Well, I got to get that x by itself, so I don't have a choice now. We're going to need a negative number. There's no way around it. Subtract 10 from both sides. Minus 2. Divide both sides by 5. And we wind up with x is equal to negative 2/5. Awesome. I got my second answer. Let's check it. Are we really going to do mental math with fractions? Please. You guys know the answer. Negative 2/5. Plug it in. I have a negative 2/5 plus 10. I need a common denominator. Stick with me. Mental math. This one's tricky. Negative 2/5 plus 10, I need a common denominator, which is going to be 5. I can't just put a 5 in the bottom of this fraction without putting a 5 in the top. So 10 times 5 is going to be 50 fifths. Negative 2/5 plus 50 fifths is going to get you 49 fifths, which I will then take the absolute value of and get 49 fifths over here on this side. 49 fifths. Positive 49 fifths. Great mental math there, adding those fractions in your head. Hopefully that worked out for you. If not, go ahead and jot it down, make a little note, but practice the mental math. It's a great way to save time. Negative 2/5, plug that in for x. Here we go. Anytime you multiply a coefficient, a constant, by a fraction, the number just goes into the numerator. So 4 times a negative 2 is going to be a negative 8/5. Negative 8/5. But now I have a minus 8. Well, in order to add those, I apologize, in order to subtract those, I need a common denominator, which means I'm going to need a 5 in the bottom. But I can't put a 5 in the bottom without also putting a 5 in the top. 8 times 5 is 45. So I have what we got here, a negative 8/5, negative 8/5 minus 45 fifths. Add the opposite. You wind up with negative 49 fifths. Well, we got positive 49 fifths on this side. We get negative 49 fifths on this side. Are those equal? No. No, they are not equal, which means that this is not a solution. You did all of the algebra correctly, because I did it. It's right. But we still get an answer that doesn't work when we plug it into the original solution. It's extraneous. That takes care of this problem on this page of the notes. We'll get more practice with extraneous solutions on the next page. Head on over there. I'll meet you over there.